Ask what? Grade third. Hello, everybody. Welcome, welcome. Alrighty. Hopefully, we got a lot of people coming in. In the meantime, while we wait for more people, just a quick question. What grade are you guys in? Just curious. And also, maybe, I guess, is anybody watching the current World Cup game? I feel like that's what people have been doing recently. Hello, hello. What grade are you in? Plus. Which
Grade
World Cup team?
7. What World Cup team are you rooting for, Eddie?
I don't think I've been rooting for a team in particular. It's just any underdog. Like, I just want to see interesting soccer. Like, there's been a lot of like 0-0 games. Like, as soon as it's like a 3-2 or like a 3-3, I think that's really exciting. Yeah,
Yeah,
Japan. Japan did
Right.
crazy upsets.
Yeah. That Japan goal, I think the second one was it? That was wild.
There was like I saw a thing. This is kind of related to math, where it's basically showing you how not mathematically figure it out, but like let me see if I can find it. But basically, the argument is that from the angle they showed it, it's clear you can't tell, right? But you can draw lines and manipulate it in a way that actually makes it show what it looks like. I want to see if I can find it right now.
Wow.
But in the meantime, who are you rooting for, Kevin?
Probably Brazil.
Brazil?
Yeah, it was Brazil and USA, and then USA lost today, so.
Right. Yeah, they lost a few hours ago. Uh, okay, I found it. So basically, it looks like this. Oh wait, one second. So from this angle, it's like, oh yeah, no, it definitely crossed it's definitely like way over the line. You guys can see this, right? So though if you can draw the lines, so if here there's like, oh yeah, there's definitely grass in between the line and the ball, but the rule is from overhead view. What does it look like from there? And so basically you draw a bunch of these, you draw a line from that part of the ball. You're kind of creating a rectangle around it. And then you draw the line. And then from there, you realize, okay, no, the ball was definitely over the line. There was a different angle from top where you could see it a lot clearer, but using this angle, you can already figure it out. And I think that's pretty cool. Alrighty. Go France. Understandable.
Yeah.
France is kind of
That's
crazy.
looking really good, yeah.
France probably going to run again. Yeah. Although the thing about soccer is that everything is one game. It's not like, for example, basketball where it's a best of 7. With soccer, it's one game. So you never know. Anything can happen. You know, Japan beat Spain and Germany, but lost to Costa Rica. So, like, I think that's the exact opposite of everything. All right. A few things. Can you guys use fake names? I think a lot of you guys are doing that, which is great. But those of you who still have your real names, please use some like not human name, because we'll be recording this and we want to make sure we're respecting everybody's privacy. Is your name human? RC. Well, RC doesn't seem like, it just seems like a random name. So I think that's okay. Looks good. Argentina. Argentina's playing right now. What's the score? I think they just scored
I think
already, right? Yep, just 1-0. Oh, Messi scored. That's funny. Okay. All right. 1-0 now, making up a name. I wonder who AMC is. It's quite a confusing name for something like this. All right. Oh, it's halftime right now? Okay, good to know. All right. Well, I think. Okay, you're watching it right now. All right. Well, hopefully you're going to be able to focus on both at the same time, perhaps. But we got a lot of very interesting numbers in chat. 9865. Yeah, I agree with that. This one's a little weird, though. I don't know about that one. But yeah, I think you guys don't need to pay attention. I think Argentina's got it in the bag. I think game is more or less over. Maybe. Perhaps. All right. Okie doke. So yeah, we just got a lot of decimals going on in chat, which is nice. If you don't agree, you broke math. All right. Same here for last week. I was not here last week, but I appreciate that. You guys are having really fun with repeating decimals, which is nice. Maybe have you guys done this one already? We're going to be going over the 2016 AMC 8. So I'm wondering if you guys are talking about all these decimals because they use it in the 2016 AMC 8, or if it's just other stuff. Alrighty. So I think we can get started. So I'll first introduce my lovely co-host, Kevin. So Kevin's really cool. Kevin's from the great state of Texas. And not only that, but he's also made the USA JMO, which is really hard to get into. I believe it's like top 200 in the entire country. And then also just really good in the AMC competition in general. So Kevin will be joining me today for the live solve.
Yeah, and I'm joined by Eddie, and Eddie's also really good at math. In fact, he made the Math Counts national team, which is really hard to make. I think he's from Ohio, I believe. And he also has qualified for the AMC. So overall, we have a math superstar with us today.
Cool. So, okay, AMC, I think you're putting a bunch of questions in chat. I'm wondering if it's from this test. Yes, Ohio. I'm wondering if this is like in a mocking way, like Ohio. What do you mean? Of course, Ohio. What do you? Have I disappointed everybody? Ohio is a real place. I will say it's hard to believe, but Ohio is a real place. Okay, so let's start. Oh wait, okay. Whoever had it up earlier actually had it. So we have the questions up, so I appreciate you guys putting in chat, but no need. We got it in front of us. So the first question is, longest professional tennis match ever played lasted a total of 11 hours and 5 minutes. How many total minutes is this? So we're looking at a match that is 11 hours and 5 minutes. How many minutes in total? So I think this is fine. Big idea is just we need to convert these hours to minutes, right? And so knowing that 11 hours, how many minutes in an hour? Feels really basic, but that's the big question here. How many minutes in an hour? Thank you. 60, right? Pretty easy. And so because there's 60 minutes per hour, you get 11 times 60. And in this portion, that gives us 660 minutes. So we're not done yet. Make sure to add those 5 minutes. You get 665 minutes in total. So 660 plus 5 equals 665 minutes. And that's our answer. And I believe that's answer choice C. So C, 665. Little fun fact, I live like 10 minutes from the tennis tournament they do every August. I volunteered this year. So it is Ohio tennis tournament. It's called the Western and Southern here in Cincinnati. Awesome. I'm wondering if any of you guys know about that. Yes. I take that as a yes. Great. See, Ohio is a real place. Okie doke. Let's go on to number 2.
Yeah, and number 2 says, in rectangle ABCD, we have AB equals 6 and AD equals 8. So point M is the midpoint of AD, and we want to figure out the area of AMC. So first of all, the triangle's name sounds very familiar, but whenever we're doing a geometry problem, first of all, we want to draw a diagram. So for this problem, we can just sketch out ABCD. This might not be to scale. I'll try my best. So AB is 8, and then BC is going to be 6. And then we have that point M is the midpoint of AD. So we want to figure out the area of a triangle. So who can tell me a formula to figure out the area of a triangle that might be applicable here?
Wow, you guys are fast. I think you read his mind. A equals BH over 2. Base times height over 2. Thank you, MCA.
Yep, and then after that, we can see that the base here, well, the base is just AM, which is 4. Now, the height is a bit tricky because we don't really quite see what the height is, right? But we can also see that, remember, CD equals 6, I believe. So what ends up happening here is that we actually have the base of this. I'll use a different color. So our base, which is AM, is 4. And our height, which is CD, because this is perpendicular, remember, is going to be 6. So we can use the formula base times height over 2, which gets us 4 times 6 over 2, which equals 12, which is our final answer.
Cool. And I believe 12 is answer choice A, so you pick A for number 2. Cool. Alrighty. So moving on to number 3, we got 4 students taking an exam, and 3 of their scores are 70, 80, and 60. Sorry, 70, 80, and 90. I read that upside down. The average of the 4 scores is 70. Then what is the remaining score? So let's write this out. So essentially, we have a mystery score that I'm going to put as blank, a 70, an 80, and a 90. And we're told that the average of all of these is a 70. So, what is that missing value? So there's a bunch of different ways to do this. And we got some people who got the answer in chat already, which is awesome. But walk me through the thought process. What are you guys thinking? So do weighted average or algebra? Do you guys want to explain how do we go about doing this? So one way I think is to just look at the definition of an average, right? So the average of a bunch of numbers is going to be equal to the sum of all the numbers divided by the number of numbers. A little confusing, but the sum of numbers over the number of numbers. And in this case, if I say that the 4th student had a score of X, set a variable because we don't know what it is, then our expression here is going to be 70 plus 80 plus 90, which is 240, plus X divided by 4 total scores, because that's the number of numbers, and that's equal to 70. And if you multiply both sides by 4, you're going to get 280 is equal to 240 plus X. And from there we can see, okay, X is going to be 40. But I see you guys have a different solution in chat, right? So Hayden, I think, is basically rewording this type where you say the sum must be 280 since the average is 70. The average is 70. That's like saying, well, the sum should be if I just had 4 scores of 70, which would give us 280. But I think it was Billy the Bob Joe, thank you. So another way of looking at it is, I'm going to kick this out to the side. So we know the average, actually, wait, I need that back. Come back, please. Okay, it's peeking out. There we go, it's back. So if the average is 70, another way of looking at it is, okay, this number right here, 70 is fine. That is exactly on the dot. 80 is 10 more than the average, and 90 is 20 more than the average. Well, if I want it to be an average of 70, in other words, it should have the same sum as just a group of 4 70s. I need to make sure that these differences are 0. So right now I'm 0 above the average, but then I'm 10 above the average. Now with all 3 of them, I'm 30 above the average. So the last one needs to be 30 less than the average. So 70 minus 30 gives you 40, and that's another way of getting our answer 40. 40 is not the best score, so wish the student best luck. It depends, actually. On the AMC, a 40 is pretty fine. Like, AMCs are hard. But granted that scores are pretty high, I think they have some work to do. 40 is answer choice A, so number 3, we are left with 40. Awesome.
Yep, and now we can move on to the next question, which actually says that when Chinu was a boy, he could run 15 miles in 3 hours and 3 hours and 30 minutes. As an old man, he can now walk 10 miles in 4 hours. So how many minutes longer does it take for him to walk a mile now compared to when he was a boy? Now, clearly this is a rates problem. So we can, Chinu, how old is Chinu now? Let's say Chino is 120 years old, just for fun. So yeah, that's exactly right. We want to find the rates, right? Because we're comparing the difference of the rates in this question. We want to figure out, how many minutes longer it takes him to walk a mile now compared to when he was a boy. So it'd probably be best if we figured out, both of the rates, so we could figure out the time it took for him to run a mile. So let's say when he was a boy, let's say, how old do you think Chino was when he was a boy? Let's get an age. So it was okay. So when he was 1, when he was a little boy, let's say it took him, was it 15 miles in 3 hours and 30 minutes. So in 210 minutes, because we want to convert into like one sort of, I guess, unit of measurement, right, to measure time. So we're going to convert everything into minutes. He ran 15 miles. And when he was 120, it took him 4 hours, so 240 minutes, to walk 10 miles. Now, who can tell me what's the formula that we can use to relate like miles and minutes to figure out the rate? Keep in mind, because we want to figure out the rate. Who remembers the exact formula? I'll give you guys a little check mark if you want. Or I guess I'll show up as a star. Yeah, that's exactly right. So since we know that he ran 15 miles in 210 minutes when he was 1, that means he spent 14 minutes running a mile. And when he's old, that means he spent 24 minutes per mile, right? Because we're just, doing some rates here. And which means that, in 1 mile, before he spent 14 minutes, now he spends 24 minutes. So the difference is going to be 10 minutes. And that's Chinu's mile problem.
Awesome. So what was the old age at 120? You know what? Way to go for keeping in shape at 120. Honestly, on a related note, my middle school cross country coach, he was 80 and he was still running marathons, the Boston Marathon actually. So absolutely, it reminds you that the human body can do anything sometimes. Alrighty, number 5. The number n is a 2-digit number with the following properties. When n is divided by 9, the remainder is 1. And when n is divided by 10, the remainder is 3. So n divided by 9. So if I just say divided by 9, the remainder is 3. Sorry, that's not 3, that's a 9. Remainder is 3. Alright, sorry, the remainder is 1. And then when n is divided by 10, the remainder is 3. And now we're looking for when it's divided by 11, what's the remainder? Find the least common multiple, says AMC. Okay, so it's kind of weird to think of least common multiple, but if you look at just 9 and 10, there's a number when we could think about when it divides 90, what it could be. Look at the multiples of 10 less than 100. Right. And so there's a bunch of different ways to look at it. I'm going to rephrase this using a special notation called modulo. So what these 3 statements are essentially saying is n is congruent to 1 mod 9. It looks weird, but it's literally exactly the same thing. There's no difference. It's saying when it's divided by 9, the remainder is 1. And it's also saying that n is congruent to 3 mod 10. And now we're looking for what is n mod 10? Sorry, mod 11. What is n mod 11? So now that we've basically translated what the question is asking, looking at numbers that are, I think somebody in the chat said, who was it? RC. So the numbers 3 mod 10, you would just take 3, 13, 23. That's simple enough, right? And then we can look at which of these are 1 mod 9, right? So because there's only 10 of these, right, before it starts repeating itself, we can actually just list them out. I think it's definitely a good strat. So, and we got to pick which of these is 1 mod 9. So which one is it, guys? Which one of these is 1 mod 9? And there is a faster way to look at it too. And I think that's why I prefer looking at a modulo. I know modulo makes it really unnecessarily complicated, but I'll show you guys a trick in just a moment. 73. So this is the number that is both 3 mod 10 and 1 mod 9. I guess I'll box it in yellow to make it less confusing. Another way to look at it is that if I start at 3, I want to keep adding 10s such that it's 1 mod 9. Well, I'm going to actually look at all of these numbers mod 9, in fact. So 3 is 3 mod 9, right? It leaves a remainder of 3 when divided by 9. 13 leaves a remainder of 4. 23 divided by 9, well, 18, right? 18 is the nearest multiple, so it has a remainder of 5. 27 is the nearest multiple to 33, and then the remainder is 6. And it keeps going, right? 7, 8, and then we don't say it leaves a remainder of 9 here. It just divides exactly into it. It's 0. And that's how we get our 1 mod 9 at 73. But if you notice, the 3, 4, 5, 6, 7, 8, 0, that's really nice. And the reason is, this comes from the fact that 10 leaves a remainder of 1 when divided by 9. In other words, 10 is congruent to 1 mod 9. That means if I look at all these numbers mod 9, so I start at 3, every time I add a 10, that's like adding a 1 to the remainder when divided by 9. So it goes 3, 4, 5, etc. So a really quick way to go, I start at 3 mod 10, and I want to keep adding 10s so that it stays 3 mod 10, but I want to get to n equals 1, congruent to 1 mod 9. How would I do that? Well, you can already, instead of going 3, 13, 23, I know for 10s it's not that bad, but say you had like 13s, you're looking at multiples of 17s. It might be easier to just only look at the remainders. 3, 4, 5, 6, 7, 8, 0. Bam, that's your 1 mod 9. So already we know that 73 is a number that works, right? And so since 73 is a number that works, all we have to do is what is its remainder when divided by 11? And from there, 73 mod 11, here I'll place the 73. 73 mod 11, the nearest number would be 66. 66 to 73 is going to give us 7. So that our answer is answer choice E, 7. I believe it's E, right? Yep. Cool. Hopefully that clears up modulo a little bit.
Yep, and with that, we can move on to our next question. And this one's going to have a bar graph, because I know you guys all love bar graphs. And this bar graph is a little special because we have the length in letters of the names of 19 people. So we want to figure out the median length of these names. So what the median, so I guess first of all, median is kind of a fancy word, right? So you can tell me what median actually means. So if you have a median of like some list, right? What would that mean? Yes, that's exactly right. Vocab word of the day. Median is going to be the middle number. So if we have 19 numbers, right? So we have, because the bar graph has 19 people in it. So we're gonna have basically 19 different things in our list. So what would the middle element be? Like, I guess another way to say it, right, was if we have 19 like things in the list, right? Let's say this had position 1, position 2, etc. What would the middle like position be, if that makes any sense? Yeah, exactly, the 10th number. So basically, if we sort this like all these different things, all these different, I guess, people's like names as lengths in the graph, what we'll end up getting is like if we sort it in increasing order, right? We'll have a bunch of 1s, so we'll have a bunch of 1s, we'll have a bunch of 2s, a bunch of 3s, and so on and so forth. And we want to figure out the 10th smallest length in the list. So let's get started, right? Obviously, for, number 1, so like length of 1 is going to be the smallest in the bar graph, or sorry, length of 3 is going to be the smallest in the bar graph. And we can see that, we have 7 people who have the smallest length, which is 3. Now, when we get to length of 4, we can see that we have 3 people with the length of 4. So if we care about the 10th smallest person's length, right? What that means is that we'll have 7 from here. So the 7th smallest will have a length of 3, but we add 3, right? So the 10th smallest will have a length of 4. And aha, that's the median we care about. So our median for this problem is going to be 4, if that makes any sense. And so the main idea for this problem is we just want to figure out what median means. Now we know it means the 10th element, so we just go from smallest to greatest and we figure out exactly what length the 10th smallest element has.
All right. So, bit of everything so far. Got graphs, got number theory, got algebra. Let's talk about which of the following numbers is not a perfect square. So these are really big exponents, but there's a pattern going on. We got 1 to the 2016th, right, starts at 2016. Then 2 to the 2017th, then 3 to the 2018th, then 4 to the 2019th, and finally 5 to the 2020th. Which of these is not a perfect square? So I see RC right away mentions odd exponent. That's a really key detail because we can eliminate everything that has an even exponent. Well, first of all, 1 to the 2016 we know is just 1, and that's definitely a perfect square. So I think we can see that one pretty easily. From there, every even exponent, so it comes from the key idea that 3, like anything, I'm going to use 3. 3 to the a to the b is equal to 3 to the a times b. Why is that? Well, basically what it's saying is, I guess I'm going to go off to the side a little. Imagine I had 3 to the a, then to the b. This is saying multiply 3 to the a times 3 to the a, la 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 la. How many times? B times, right? Actually, I'm going to color code this differently. So I want to do this b times. Well, 3 to the a already says multiply by 3 a times, right? So it says do this a times, multiply by 3 a times, and then multiply this way b times. So the amount of 3's I'm multiplying by in total is going to be, it's like an array, right? It's like a rectangle. It's a times b times in total, right? So that kind of proves our idea that if you raise something in a parentheses to something outside of it, 3 to the a times b. So even though we don't see that here, the idea is that we can work that backwards. Anything is a perfect square as long as we can express it as some integer, some number, and then the exponent 2, right? And so that means 3 to the 2018th we can write as 3 to the 1009th squared, right? Because if I expanded this out, I would get 3 to the 1009 times 2, which is 2018. So I don't know what 3 to the 1009th is, but the big idea is that this is a square number. It's this thing inside squared, which means I can do the exact same thing for 5. This is 5 to the 1010 squared, which means already that's not a square, that's not a square, that's not a square. We're down to these two. 2 to the 2017th or 4 to the 2019th. What's nice about 4 though is that it is a perfect square. 4 is 2 squared, right? And that means, for example, if I just took 2 squared, sorry, that's 4, right? If I took 4 squared, that would be that. If I took this squared, it's just a bunch of 2's. And no matter what, I can always take this side, and that squared gives me that, right? So if you think about what square rooting does, it's like cutting the exponents in half if it's like multiplying, right? So 4 to the 2019th, it's just going to be a huge row of 2019 2 times 2's, and the square root of that is going to be just one of these columns. So 2 multiplied by itself 2019 times. So in other words, 4 to the 2019 would still be a square. It's 2 to the 2019th squared. And another way you can do this using the fact that we had earlier where 3 to the a to the b is equal to 3 times a times b, this can be written as 2 squared to the 2019th. Or in other words, 2 to the 2 times 2019, right? I'm going to delete this. So this can be written as 2 to the 2 times 2019, which means you can also do it backwards. We can do this as 2 to the 2019 squared. So it's still a square as well. And from there, we know that the only one that wasn't a perfect square is answer choice B. I'm pretty sure I used the lime green for that, but if not, oh well. So this is not a perfect square.
Yeah, and we can move on now to the next problem. Problem number 8. And this basically wants us to figure out the expression. Wow, we have a lot of people who already solved the problem before I even finished reading it. The value of the expression 100 minus 98 plus 96 minus 94 plus 4 minus 2. So to do this problem, obviously, we probably don't want to compute the whole thing by hand, right? So we want to figure out an easier way to do this problem. And I'm thinking we probably want to cancel some terms so we can get an expression that makes this problem, I guess, more doable. So let's look at the expression real quick, right? So we have the value. Let's see. We have the value 100 minus 98 plus 96 minus 94 plus so on and so forth plus 4 minus 2. So I'm already seeing a lot of great ideas in the chat, but let's take one step back for a second, and let's just say, how can we group these terms up? Because we want to make this cancel somehow, right? We don't want to add and subtract like 50 terms. So how can we group these things up so they'll cancel and we have like something very simple to deal with? Exactly, right. Pair them up. And also agree, Messi's better than Ronaldo. Break them up to negative and positive numbers. That could work, but it might be a little tedious, let's just say. Oh yeah, that's also a great idea from AMC 12. So, yeah, exactly. We can see that they pair up into -2. So, basically what happens is that we see that we can pair up 198, and this equals 2. We can pair up 96 and 94, this equals 2, and so on and so forth. And we can pair up 4 and 2, and this equals 2. So we have a bunch of different pairs that all equal 2. But the question is, how many pairs do we have in total? Exactly, Hayden and Chan. We have 15 numbers, and which means that there are 25 pairs because we can see that there's 50 numbers because it's all the even numbers all the way up to 100. So 50 numbers, and 2 numbers make a pair. So there's 50 divided by 2, which is 25 numbers. And what this means is that we have 2 times 25 because each of these pairs has difference 2. So our final answer is 50.
Alrighty, so moving on, I think we're chugging through this pretty fast. We got number, where is it? Number 9 next. What is the sum of the distinct prime integer divisors of 2016? So, oh yeah, there seems to be like a little bit of noise. Wonder who it's coming from. Make sure you're muted if there's some noise. But yeah. Right now, we're just looking at 2016. And basically, our best bet is to try and prime factorize this. So I think the easiest thing we can do is find, well, it's always great to start off with 2s or 3s, right? But right away, since it ends in 16, I'm going to divide by 8, actually. Because I know 1,000 divides 8. So 8 goes into 1,000. So that means it should go into 2,000, right? And it goes into 16 as well. So that means it should be divisible by 8. So if I divide this by 8, I'm going to actually color code this too. So 8 divided by 2016, that goes in there twice. 51. Sorry, 10 minus 6 is 4. And then 5 times 8 is 40. You get 252. So that's 8 times 252. Oh, it actually divides 16 as well. Wait, hold up. That doesn't seem right. Okay, well, it divided by 16 as well. So there's another 2. Actually, another 4, right? Because 52 divides... I'm writing with a pen, not a mouse. So it divides 52, so it writes the whole thing. That's going to be 63, I believe. Yes. Because 4 divides 250 times, and then there's 13 more times from the 52. And then from there, 63 we know is 7 times 9. So I said I was going to color all of this. Oops. So that's a 7, that's a 9. The reason why I colored 8 and 4 the same is because they're both powers of 2, right? So it's asking for the distinct prime integer divisors. So it's all about the distinct prime integer divisors. So it's also not just distinct, it has to be prime, right? So if we were to like combine everything up together to get the prime factorization, normally you would say 8 times 4, that's 2 to the 5th in total, times a 7. Okay, wait, sorry. First the 9, which is 3 squared, right? And then the 7. But the problem is just asking for the prime divisors. And so the prime divisors right here, 2 plus 3 plus 7. And that's 12. I believe that is answer choice B. I think I've been getting a lot of B's.
Yeah, that's exactly right. And now we can move on to the next question. And this one seems to be a little more simple, but still a very interesting problem. And what this one says is basically that, so what this one says is that basically we have this expression. So we have this binary operator, which basically says that A star B is going to equal 3A minus B. And we want to figure out the value of x if 2 star 5 star 1 is going to equal to, or sorry, 5 star x equals 1. So we want to figure out what x is. And so the way we want to do this is, first of all, we can see that since we have A star B equals 3A minus B, it's probably just smart to substitute all the stars for 3A minus B every single time. So for example, remember, we need to be careful because of our order of operations. One other thing I'll say is that if you just say the answer, like, it doesn't really contribute to the discussion. So if you want to like share how you did the problem, that'd be a lot better than just sharing the answer. So that way we can build off of your ideas, and that'd be a lot better. Just for everyone's like reminder, I guess. Anyway, so remembering our order of operations, we can see here that we want to do the largest term first, right? So we can see that this is going to be 3 times 2 minus b, which is, in b in this case would be 5 star x equals 1. So we can convert this as 5 star x is going to be 3 times 2 minus 1, which is 5. So we have that 5 star x equals 5. So which means that since we have a star b equals 3a minus b, 5 times 3 minus x is going to equal to 5. So here we can see that x is going to equal 10, and 10 is our final answer. Yeah, that's exactly right.
All right. I feel like they do a lot of these types of make up a random function and then do something with it. And so just take it step by step, and they're usually not that bad. So pretty cool stuff. Although they definitely do make really complicated versions of that. Alrighty. So on to number 11. Alrighty. So with number 11, determine how many 2-digit numbers satisfy the following property. When the number is added to the number obtained by reversing its digits, the sum is 132. So in other words, it says if I have a number that looks like AB, as in like it has a digit A and then a digit B, if I add this to BA, I get exactly 132. So what's really nice about this? Okay, right away, IMO says 66. That's a good example, right? So 66, I reverse the digits, it's still 66, and I get 132. So that's one of them. And we could keep going, but there's actually a really nice trick with these types of problems where you have digits. I can't do anything with this because, this is a tens, like this A is in the tens place, while this A is in the ones place. They're different, right? And so, oh, we got more coming in. So for example, 57 works as well, right? 57 plus 75 is also 132. But there's definitely a more systematic way we can do this. And there's this one trick to rewrite a number that has A in the tens digit and B in the ones digit. The big idea is I want to use the digit A. Because like, for example, if the digit is like 7, if A is 7, in this number, it really has a value of 70. But this has a value of 7. So algebraically, what this is saying is that the first number is 10 times the tens digit, right? Plus B, because that's what it means, right? That's what it's literally saying. And then the second number is 10 times B plus A is equal to 132. So now we can combine these. 10A plus A should be 11A. And 10B plus B should be 11B. And what's nice about this? What can I do? What can I do with 11A plus 11B is equal to 132? What's super nice about this that I can simplify? Factor 11, way to go, right? All of these are multiples of 11. So this has a factor of 11, this has a factor of 11, and 132 is 11 times 12. Remember the trick for multiplying by 11, split it open, 1 plus 2 is 3, bam. Okay, so if we divide through by 11, we have to divide every single term by 11, right? So 11a divided by 11 leaves me with just a. 11b divided by 11 leaves me with just b. And that on the right hand side is equal to 12. So in other words, it's saying is, as long as a plus b equals 12, this should satisfy the original expression. And it's true, because look, 66 worked, right? And the digit a, which is 6, and the digit b, which is 6, 6 plus 6 is 12. 5 and 7, that's also 12. 5 plus 7 is also 12. So in other words, I'm just looking for all pairs of digits that sum to 12. So let's look at that. For a plus b equals 12, I could do anything from 9, 8, 7, 6, 5, 4, 3, 2. I'm going to stop there for a because for b, if a is 9, then b has to be 3. If a is 8, it has to be 4, and so on. But remember, a and b represent digits. So once I get here, b can't be 10. You can't have the digit 10, right? That's not how it works. So that's not a possibility, and these are all of our possibilities, right? And remember, the original question is just saying, determine how many two-digit numbers satisfy the following property. So I guess converting these into two-digit numbers, that's 93, 84, etc. And if you have extra time, you can always go ahead and verify that these are true. But given our algebra, we should be pretty confident that this is true, right? And so 7 numbers in total. Our answer is B. So for number 11, the answer is B, which is 7. That was a really bad box.
Yep. And now we can move on to question 12, which has Jefferson Middle School has the same number of boys and girls. So 3/4 of the boys, or 3/4 of the girls, and 2/3 of the boys went on a field trip. So this one's a bit tricky because the question is, what fraction of the students on the field trip were girls? So let's see here, right? So we know that we have an equal number of boys and girls. So let's just say there are X boys and X girls. So we know that let's see, 3/4 of the girls, so 3/4 X of the girls went on the field trip, and we know that 2/3, so 2/3 X of the boys went on the field trip. So the total number of people who went on the field trip is 2/3 X plus 3/4 X which equals 17 over 12x. Now, hopefully I didn't make any silly mistakes, but now we can figure out, now we know the total number of people who went on the field trip. So how can we figure out what percentage are girls? Does anyone have any ideas on how we can figure that part out? Yeah, that's exactly right. So basically the idea is that we have 17 over 12x of the total people, or 17 over 12x is the total number of people who went on the field trip. And now we can see that we want to figure out the number of, or the fraction of girls that went on the field trip, right? So we see that, 3/4 x is the number of girls that went on the field trip over 17 over 12x, which is a total number. So essentially the fraction we want is the number of girls divided by the total number of people. So we have 3/4 x, which is the number of girls, divided by 17 over 12x, which is the total number of people. And this results in, just doing some cancellation, we can cancel the 4 out of the numerator and the denominator, we can cancel the x. And so what we end up getting is that we get 3 over 17 over 3, which results in 9 over 17. That's the fraction of the field trip goers that are girls.
Alrighty, on to number 13. So 13, we have a set of 6 numbers and they're multiplied. So 2 of them are picked and they're multiplied together. What's the probability that the product is 0? So the numbers go like this. They are -2, -1, 0, 3, 4, 5. So we want to pick 2 of these at random and the probability that the product is 0. So we want the probability that the product is equal to 0 of 2 numbers. Well, this is obvious a little, but it's definitely helpful to start the problem. What do I need in order to get a product of 0? So yeah, it has to be 0 itself, right? You have to pick 0. It has to be 0 times something, whether it's something times 0 or 0 times something. So something times 0 or 0 times something. Those are the only ways I can get a product of 0. But the thing is, it says 2 different numbers are randomly selected from the set and then multiplied together. So in fact, it doesn't matter what order they're in. All I need is that I need out of the 2 numbers I pick. So imagine I pick 2 numbers, they go into this green set. 0 has to be one of them, right? So there are how many other numbers in the set? Well, there's 5 numbers. So any of the other 5 can go in here. So there are 5 total ways to make a pair such as has 0 and some non-zero number, right? So there's 5 correct ways. So remember, with probability, we always want the good ways over the total ways. And in this case, the good ways is how many ways we can make a product 0. And we got that was 5. So the total ways I see you guys have in chat already are saying 6 choose 5. Sorry, 6 choose 2. Can't read. 6 choose 2, right? So 6 choose 2 literally tells us in a set of 6, out of a group of 6, please pick 2 things, which is exactly what we need right now. But what exactly is 6 choose 2? And if you're not familiar with this notation, big idea is saying, well, for example, looking at our set again, I need to fill 2 spots, right? I need to fill a number for the first one, fill a number for the second one. And I'm just looking at the total number of possibilities right now. So it doesn't matter what number goes in the first spot. I can put anything. So there's 6 possible ways to put a number in the first spot. And after I put a number in the first spot, there's 5 ways for the second spot. The problem with that, though, is that, for example, if I pick 3 and then 4, I'm also including the possibility that I pick 4 and then 3. So in other words, I've counted every set twice by doing this. Like the pair 3 and 5 and 5 and 3 are both in 6 times 5. But I only need it once, right? Because order doesn't matter. They're the exact same thing. So after I do 6 times 5, I have to make sure to divide by 2. And that's literally what the expression is. 6 choose 2 is equal to 6 times 5 divided by 2, which is 15. So already we have our total ways is 15, and the good waste from earlier was 5. So 5 divided by 15 should give us our answer of D, which is 1/3. Awesome. Oh wait, this is number 13, sorry.
Yeah, and now we can move on to number 14. And number 14 basically says, oh wow, it's another rates problem. So Carl's car has a gallon of gas every 35 miles, and his gas tank holds 14 gallons when it's full. So one day, Carl started with a full tank of gas. He drove 350 miles, bought 8 gallons of gas, and continued driving to his destination. So this question is, first of all, it's a mouthful, so we want to be very careful. And second of all, it says that basically we know the rate that the car uses gas, right? And we also know the gas tank holds 14 gallons when it's full. So I guess we can try to keep track of all the important points in Carl's journey and see how much gas he has left. And maybe that will determine how many miles he totally drove. So first of all, we know that at 0 miles, so we'll count by miles. This is his trip, let's say, right? And say 350 and end. So we have 3 points we want to keep track of, right? So at 0 miles, Carl has 14 gallons of gas. So he has 14 gallons of gas. At 350 miles, and so he bought 8 gallons of gas. So he has plus 8 gallons of gas. And then when he finally arrived, his gas tank was half full. So he has 7 gallons of gas when he finally arrived. Because his total is 14. So we can see here that we want to figure out the total distance, which let's just say is x. So first of all, we can try to think about how many total gallons of gas Carl used, right? Because if we can figure out that information, then we'll figure out exactly how many miles he drove, because we know he uses a gallon of gas every 35 miles. So how many miles exactly, RC. So how many miles did Carl, or how many gallons of gas did Carl total, or is that his name? How many gallons of gas did Carl totally use over the duration of the whole trip? Does anyone know how we could calculate that? So how many gallons of gas did he use, and how could we figure that out from our current setup? Well, one way we could figure out is basically we have 14 at the start, right? And then at the very end we'll have plus 8. So we have 14 first, and we'll add 8, and then we know that finally we'll have 7. So right, so basically we have total, or I guess we can think about this as, so we have 14 and we're going down to 7. So without this plus 8 here, we'll be using 7 gallons of gas. But we also have the plus 8. So after the plus 8 refill, which means this plus 8 is also this gas is also gone. So we have a total of 15 gallons of gas that that we used during the trip. And so we know that each gallon of gas gives us 35 miles. So using that rate, we could figure out that the total number of miles is going to be 35 times the number of gallons of gas. In other words, it's going to be 525, which is our answer. And yes, Carl does like driving a lot. I'm sure he also likes driving in an RC.
Yes, nice. I know a lot of people who like driving. They just go around the country. They're like, oh, just going different places. Even just in the car, already super cool. Alrighty, so for the next one, number 15, we're looking for the largest power of 2. That's the divisor of 13 to the 4th minus 11 to the 4th. Now, I'm pretty sure these aren't too bad. I think I know these off the top of my head. That's 2197, and that's, wait, that's not right. That's 13 cubed. Okay, I don't know 13 cubed off the top of my head. 11 to the 4th is going to be 14641 though. So 13 to the 4th is already even bigger than that. These are really big numbers. I don't want to do that. So we're thinking about powers of 2. So already I know that I don't want to just straight up, crank out the numbers. So what's our best bet? What's really nice about this expression? What should we do? fourth powers aren't fun, but thinking about the exponents and the perfect squares maybe that we were doing earlier might be useful. Yes, okay. So a lot of people are saying factorize it, right? So basically, it might not seem like it since it's powers of 4, right? But we have exactly 13 to the fourth, which is a square, right? In fact, it's 13 squared squared, using the idea from earlier. So 13 squared squared minus 11 squared squared, and bam, these are differences of two squares. And that's equal to a minus b times a plus b. So I'm going to write it off a little bit to the side. A squared minus b squared is equal to a plus b times a minus b. So that means this is going to be equal to, I'm going to set up the parentheses like this, plus minus. So let's make it red and orange. How about that? This is going to be 13 squared plus 11 squared times 13 squared minus 11 squared, right? And so from here, what can we do? So we factorized it to this point. And unfortunately, what's already nicer though is that 13 squared and 11 squared are much more doable. We can deal with those. That's 169 and 121. So we can absolutely just keep going. But your mom is shouting about the World Cup is distracted. That's okay. So we could solve it, right? But I actually want to go one step further because we can actually do it again, right? On this one right here. 13 squared minus 11 squared should give me 13 minus 11 times 13 plus 11, right? And so that would be convenient as well. So even though I know you guys can definitely subtract it, it's not that bad. But this just literally straight up says 13 plus 11 we know is 24. 13 minus 11 is 2. So 24 is 8 times 3. So right away, that's a power of 2. That's a power of 2. Now we got to check how many powers are 2 are in 13 squared plus 11 squared. That's just 169 plus 121, which I believe is 290. So that's 290. How many powers of 2 are in 290? Well, at least 1, right? I can divide it by 2. And then that becomes 145. So just 1, 2, and no more. So in other words, within 13 to the fourth minus 11 to the fourth, there's a 2 times 8 times 2. 2 times 8 times 2 is 32, which means our answer is answer choice 3, 32. Awesome.
Yep, and now we can move on to question number 16. Wait, it's always me who gets the rates problem. I think it's like the 4th rates problem I've done now. And this one says, Annie and Bonnie are running laps around a 400-meter oval track. They started together, but Annie has pulled ahead because she runs 25% faster than Bonnie. So how many laps will Annie have run when she first passes Bonnie? So this is a pretty interesting question. And one way we could start doing, or one way we could look at this, right, is that Annie is 25% faster than Bonnie. So if you think about this, right, if Annie is 25% faster than Bonnie, so I guess it might make sense if we think about it in terms of laps, right? So if, let's say, Bonnie runs 1 lap, right? 1 lap. That means that Annie would run 25% more. So it would be 5/4 laps. So after, if you think about like after one, let me see. So after like 1 lap from Bonnie, right? The difference between Annie and Bonnie are going to be 1/4 lap. So after every lap that Bonnie runs, Annie is going to be 1/4 of a lap ahead. So what this means is that since we know in total, when she first passes Bonnie again, that means that their difference in the number of laps is going to be exactly 1. What this means is that we'll have 1 lap of a total difference equals the number of laps that Bonnie runs times 1/4 of a lap. So the Bonnie in total runs 4 laps. So we might just be tempted to circle 4, but that's actually the wrong answer because we want to figure out the number of laps Annie has run. So when Annie first passes Bonnie, she's running 1 more lap than Bonnie, which means that the total answer is going to be 4 plus 1, which actually gives us 5, which is the actual answer.
Awesome. Moving along on to 17. So an ATM password at Fred's Bank is composed of 4 digits from 0 to 9 with repeated digits allowable, except no password may begin with the sequence 911, which is reasonable. How many passwords are possible? So essentially, this ATM password can be anything from, so 4 blanks, and any of these can be 0 to 9. So 0 to 9 for any of these spaces, except any sequence that goes 9, 1, 1, something is not allowed. So again, let's just do this. Let's first count how many total ways there are in total, just any sequence without restrictions, and then we'll subtract out the ones that aren't okay here. So how many are there that are okay in total? We have 10 options for each space, right? Because there are 10 digits in 0 through 9. Perfect. So RC starting off 10 times 10 times 10, right? Because that's just 10 options for each space. And that gives us 10,000. So there are 10,000 options normally, right? Except how many options are no good? Well, 911 and then any 10 numbers can go here, right? So there's 10 options for this one, which means 10,000 combinations are in total, but 10 of them are no good. So our final answer is going to be D. D, which is 9990. Pretty fast.
Yep, and now we can move on to question number 18, I believe. We're on a roll right now. And basically this one says, in an another rates question. So in an all-area track meet, 216 sprinters enter a 100-meter dash competition. So the track has 6 lanes, so only 6 sprinters can compete at a single time. And at the end of each race, the 5 non-winners are eliminated, and the winner will compete again in a later race. So how many races are needed to determine the champion sprinter? Well, first of all, we can see that, so, you know, in the beginning, we have 216 sprinters. And at the end, we're gonna have 1 sprinter. So who can tell me how many sprinters do we need to eliminate, basically, through each of these races? How many sprinters do we need to eliminate in this question? To go from 216 to 1. Yeah, that's exactly right, Bob. It's 215. So we want to get rid of 215 sprinters through each of these races. And we can see that exactly RC and actually the Bob Joe. We're going to eliminate 5 sprinters from each race after each race. So the total number of sprinters we're going to eliminate is 215. In each race, we can eliminate 5, and that means we need 43 races, which is just 215 divided by 5, to eliminate all the sprinters and go from 216 to 1. Is this track meet international? Yeah, it's like the World Cup of track, basically. So we have all the different countries, and they each have 1 sprinter, and it's one to figure out who the best country is, basically. Nice, 20 stars. I'll give you 21, just because you're so cool.
Alrighty. Pretty fast overall, I feel like we've been chugging along these problems. Alrighty. A lot of world international sports tournaments. Earlier I was talking about tennis. We also hosted the World Ultimate Frisbee Championships, which is pretty cool. A lot of nations, teams from different countries coming around, so that's awesome as well. Alrighty. So the sum of 25 consecutive even integers is 10,000. What is the largest of these 25 consecutive integers? So we have 25, it said even, right? Yep, even numbered. Consecutive even integers. And their sum is 10,000. and we're looking for the largest. So what number do you think would be the easiest to find first to start with? Because, we could think about like, oh, if we start at the lowest number, we could start with x, then it's x plus 2, x plus 4, so on and so forth. But, you would get to like x plus 48, right? And that's not that fun. So, RC, I know you say so, but I actually like this idea. Divide 10,000 by 25 to get 400, and then make a list. Okay, so I agree. But what is the 400? What does 400 represent in this list? Because we have a bunch of integers, and we have a sum of 100. So a sum of the list of numbers. So we took the sum of numbers, and we divided by 25, which is the number of numbers. What is that equal to? This entire expression is the middle number, right? In other words, the average. Really good. So right away, that gives us the average of all the numbers. 10,000 divided by 25, which is equal to 400, is the average, which means we're going to start at 400, and this is the middle number, right? What's nice about an odd number 25 is that if this is the middle number, there's going to be 12 numbers this way, and there's going to be 12 numbers this way. So I want the largest one, right? Which means I only care about going this way. Right. So if you think about the number that's immediately after 400, it's consecutive even, right? So it's going to be 402. So for going one step, I added 2. And I need to go 12 numbers over. So I need to go 12 steps over, right? I like the word using steps, right? And so since each step is 2, I have to go up by 2 12 times. So in other words, I need to add 2 times 12, 24. So 424 should be the largest number in the list. And that is going to be answer choice E. So our answer is E, 424. Oh, that's off screen.
That's exactly right. And now, wow, we're almost getting to the 20s. Actually, we are getting exactly to 20. So number 20 says the least common multiple of A and B is 12, and the least common multiple of B and C is going to be 15. So we want to figure out the least possible value of the least common multiple of A and C. Well, to do this problem, there's actually a lot of ways to do this, and if you've done math for a long time, you might just realize that, let's see. So we have, the least common multiple of A and B is going to be 12. The least common multiple of B and C is going to be 15. So there's a lot of ways you can do this problem, but I'll show the way I like to think about this is actually pretty cool. So you can think about the least common multiple, right? So like, let's say we have the least common multiple of 2 numbers. Basically, what this means is that it's always going to be less than or equal to the product of the 2 numbers itself, right? Just kind of by definition, right? Because least common multiple is always going to divide A times B. So we can say that the least common multiple is going to be always less than or equal to A times B. And similarly, we can say that the least common multiple of B and C is going to be less than or equal to B times C. So we can see that, basically A times B, because of this, we can see that, so because of this, we can see that A times B is going to be greater than or equal to 12. B times C is going to be greater than or equal to, I believe, 15. So we want to figure out the least possible value of A times C. Given this, let's just hypothetically, let's just suppose that A times B is going to be greater than or equal to 12, right? And so we want to minimize A times C. So what that probably means is that we want to make sure that A times B and B times C is going to be as small as possible, right? So what this means is that let's just hypothetically, we're not quite sure if this is going to work or not, but let's just take a leap of faith. Let's just say that A times B equals 12, and then B times C equals 15. And because if we know that if these 2 conditions hold, the result is going to be the least possible value of A times C. And solving this, we can obviously see that B is probably going to be equal to 3 because both 12 and 15 are a multiple of 3, so we can assume that B is going to be 3. Now A is going to equal 4, and then C is going to equal 5. So just to summarize, we can see here that if we assume that A times B equals 12 and A times C equals 15, we get that A equals 4, B equals 3, and C equals 5. So the least common multiple of A times C, the least common multiple of A times C is going to be 4 times 5, which equals 20. And that's our final answer.
Alrighty, final 5. So with number 21, we have a top hat that contains 3 chips and 2 green chips. This is not a top hat, but it is a hat. So okay, I don't have chips. But we draw a chip randomly, one at a time without replacement, until either all 3 of the reds are drawn or until both green chips are drawn. What is the probability that it's the 3 reds that are drawn? This is a really interesting question. I actually like it a lot. Nice hat. I'll wear it for this one. Okay, so got a beanie. Okay. It's not that cold, so I'm probably going to be steaming after this. But so we're going to just be drawing a bunch of chips. And here's the thing. Instead of counting, okay, well, first of all, the game either ends if the reds are drawn or the greens are drawn, which means one of these are going to be guaranteed to happen, right? So I know it sounds obvious, but this is a helpful fact because instead of counting, we're looking for this, right? The probability that this one happens instead of this one. Instead of looking for reds drawn, because remember there are 3 reds, right? 3 reds and 2 greens. I'm going to find the probability that this happens, and then subtract that from 1. So what I'm saying is that this should be equal to 1 minus the probability of the greens being drawn. So let's just count all the possibilities that the greens are drawn. Okay, so here's the thing. What happens, less greens than reds, we can eliminate C, D, and E. Okay, wait, so this is using the answer choices, which is great. Yeah, this is actually really good logic. So the answer choices, C, D, E, are all 1/2 or greater. And so since it's intuitively, you would be like, it would probably be harder to get all the greens to be drawn. So that means we should have less than 1/2 probability, right? So there's a bunch of different ways to do this. You can list all of them since there's not that many. Actually, let's just list all the possibilities because there's not that many. And the reason why, so like listing, it just shows you that it's possible to like just write it all out in one sitting. So if you're absolutely lost, this is absolutely the way to go. It gets you the right answer. I know it just looks like I'm writing a bunch of R's, but one moment, I'll fill in everything else in just a second. I'm kind of just doing a very systematic way of writing everything out right now. I don't know if you guys can tell what the pattern is. And then the rest gets filled in with greens. So essentially, I have to know which one happens first in all of these. Is it the 2 greens or the 3 reds? And in this case, it's going to be, oh wait, so intuitively, yeah, can do RG, RG, R. Right. So these are, although if I just took all 5 of them out, this would be the list, right? But for example, the first one would just end right here. I took out 3 R's, it's done, right? And so which of these are valid? This is 3 reds, this is 3 reds. Here's the thing though, I'm only comparing the last green and the last red. In this one, the last green comes before the last red. So this is an invalid one, it doesn't work. This one, the last red comes before the last green, right? Or in other words, if the last one is red, it's game over. So I can ignore those, this is fine. And then bam, there's only 4 possibilities that work out of 10. So it's 2/5. But another thing is to just go, okay, I'm gonna count the probability that we get a green correct, right? So in order to get greens correct, I can't have 3 reds drawn. In other words, this is a little weird to think about, but I'm only just going to think about drawing 2 greens and 2 reds. Because if you think about it, any arrangement of this, what happens is, if it, for example, like this, green already wins. I drew out the 2 greens, right? But what if I had like red, red, green, green? Well, where's the 3rd red? Well, as long as I put that 3rd red after the greens, I've had the greens win, right? So my point is, by arranging the 2 greens in this group of 4, I'm guaranteeing that there are 2 greens, or in other words, that the greens win, because I only need 2 greens in order to win. If the greens win before that, then great, that's fine. If they don't, like in this example, you put the last red after it, and then the greens win. So in other words, every winning combination can be made by some combination of green, green, red, red. How many ways are there to do that? Well, there's 4 spots and I need to put greens and reds, right? But if I put like, so normally to arrange 4 things, we would do 4 factorial, 4 times 3 times 2 times 1. But I don't need to do that here because, for example, if I put a green here and a green here versus putting a green here, I'm lagging a lot. Putting a green here and a green here, it's the exact same. So the greens are interchangeable, which means I need to divide by 2, technically 2 factorial. And the reds are the same by the same logic, so I need to divide by 2 factorial for that as well. In other words, I just did 4 choose 2 because I'm choosing 2 spots for the greens to go, right? So, oh, this is funny. This is called semantic satiation, I learned the other day. It's where you say a word so much that it loses its meaning. And it happens so much that there's a word for it. So little fun fact there. But yeah, 4 choose 2 is useful because I'm picking 2 spots out of the 4 for the green, right? And then I could have also used the same logic by saying I pick 2 spots for the red, right? And then the greens fall into place. So there's 4 choose 2, which is 6. There's 6 total ways to arrange greens and reds. Remember, this is kind of a shortcut without listing. I know I said it a lot. I've been spending a lot of time explaining this, but this is actually faster than listing because what I've just said is rearranging GGRR in any sort of fashion gives me a valid arrangement. Because again, either GG comes before it ends, in which case it wins. But if it's like RRGG, well, if I put an R after it, the last red comes after, and therefore it's a valid arrangement. No matter what way I arrange GG and RR, I'm going to have a case where green wins. So there's 6 cases out of 10 where green wins. Bam. And by the way, so I know this is more than 1/2, so it feels like it's counterintuitive. But the reason why I picked G is because it's easy. It's easier than thinking about 3 reds. Although actually, I just realized you can do the exact same logic with 3 reds. So if you did RRR G, if you rearrange any of this, you either get 3 R's already and bam, you win. Or if there's a G that comes before it, if you put the final G afterwards, actually, if you can think of just putting a G after every single one, then that's a valid arrangement. You just save the G for last. As long as the G is the very last one, it works. Oh, I just realized. Okay, the problem, an even faster way to do everything, thinking out loud. There's going to be guaranteed, in these 5 spaces, there's guaranteed to be something in the last space. I know it sounds obvious, but the last one has to be red or green. And since I said that the game is a battle of whether the last red or the last green comes first, if you show up in the last spot, well, obviously you're last. So as long as you don't show up in the last spot, you win. So we want red to win, right? For red to win, I need G to show up in the last spot. For G to show up in the last spot, there's 2/5 chance, right? 2 out of 5, because there's 2 green chips out of 5 total. So there's 2/5 chance that red wins. Bam. There's a 2/5 chance that green is the last one. So there's a 2/5 chance that red wins. 2/5. That's answer choice B. Okay, that was a lot, but I think that's a really nice way. A lot of thinking out loud that went from the least fast solution, a faster solution, to the fastest solution. All right.
Yeah, and that also kind of shows why it's so important. Even if you solve a problem, like always look at the solutions because you might see like something really cool and unexpected, and that'll teach you a lot. As you know, Eddie just demonstrated for us. So, moving on, we can look at question number 22. So we have a weirdly labeled rectangle for some reason. DEFA is a 3x4 rectangle. As usual, my diagram is completely out of scale. So, let's say A, D, E, F. So A is going to be here, D here, E here, and F here. And we have, basically B here, C here. So these lengths are all going to be 1. And then I believe that the other length of rectangle is going to be 4. And so we're going to draw a couple of bat wings, like this. Oh, that's a bad line. So you can use your imagination here. These are lines. So we have a couple of bat wings, and we want to figure out the area of the bat wings, or the shaded region. And I realize that the second wing is really weird, but it's okay. So basically, to this problem, first of all, what would be like something easy we could do? Like to start off with, right? Yes, the infinity wing. So we won't quite worry about this wing for now. Exactly, similar triangles. And actually something else that we might notice is that since even though my diagram doesn't look like it, these two wings are actually exact same. So what this means is that if we figure out the area of one wing, we can just multiply by 2 to figure out the area of both of these wings, right? So in other words, need to find a different color. So figure out the area of this, so of this wing, and we multiply by 2, we can figure out the area of both of these wings. So what this means is that, let's look at this area of this wing, right? We know that this length is going to be 1/2. And we know that this length is going to be 3/2, and this is going to be 1. And yeah, that's, I see a lot of great ideas. Similar triangles. Yeah, that's exactly right. So we want to subtract the white parts, basically. So we want to subtract the parts that aren't in the bat wing to figure out what the actual area of the bat wing is. So first of all, we know the total area is going to be the area of the rectangle, right? Which is just 4 times 3/2, which equals 6. And now we want to subtract out the 3 small right triangles in the corners. We can see that this right triangle is going to have area base times height over 2, which is 1 times 4/2, which is 2. This right triangle is going to have, but these two right triangles are a little bit tricky because we don't quite know the height of them. But I see a great response from Fox in a Bush, actually. We can just use similar triangles, and that's entirely right. Because what we can see here is, I'm going to use a different color again, we can see that this triangle, so this light blue triangle and this other light blue triangle are actually going to be similar. And what this means is that since these are similar because of parallel lines, because remember, parallel lines mean similar triangles. So basically, since this is going to be 1/2, so the length of this, of the small base, is going to be 1/2, and the length of the large base is going to be 3/2. These triangles are similar with a ratio of 1 to 3. And since the total side length is 4, what this means is that, and since it's 1 to 3 is the ratio, this is going to be 1/4 of 4, and this is going to be 3/4 of 4. So the area of, or the length of this is going to be 3, and the length of this is going to be 1. So now we can figure out, using base times height, we can figure out that this is going to be 3 times 3/2 divided by 2, which is 9/4. And this is going to be 1/4. So we have the total area of the rectangle, which is 6, and we want to subtract out 2 minus 9/4 minus 1/4. And our final answer for one pair of bat wings is going to be 3/2. But remember, we have 2 total pairs of bat wings. So we want to multiply by 2 at the end to get a final answer of 3, which is our answer.
I feel like I heard somewhere where in an isosceles trapezoid, the area of these things is square root of the two sides it's on. I'm not entirely sure, so I want to verify that right now. But no, I don't think it's correct. So, unfortunate. Try again next time. Alrighty. So, on to, okay, I think that's a different problem actually. Number 23. So, two congruent circles centered around points A and B each pass through each other's circle center. Okay, so right away, let's try and draw that. So I'm gonna cheat and use my handy dandy. I drew this by hand, by the way. I'm just that good at drawing circles. So that's one circle, and then I'll try and make the other circle the same size. Oh, there we go. I think this is the same size. Let's go, pretty close. Okay, so the circle as center A is passed through by the one that has circle as center B. Yes, this I meant cheating as in like please don't cheat on the chat. I meant cheat as in drawing these circles, because on an actual test you're probably not going to be able to, unless you bring a compass. Wait, are compasses even allowed? I actually don't know off the top of my head because I never use one. But yeah, you probably won't be making perfect circles on your exam, so just try your best. But for the sake of explanation, here they are. And from there, the line containing both A and B is extended to intersect the circle at points C and D. So drawing this through, this hits the circle at C and D. So I'm just going to call the one on the left C, and the one on the right D. And then from there, it asks for the circle intersects at 2 points, so 1, 2, and one of them is E. So I'm just going to designate the top one to be E. What's this angle measure of CED? So we're looking at sort of this angle right here I have in pink, CED. How can we go about this? Okay, that's really interesting. 90 plus 90 minus 60. Where did you get the 90 plus 90 minus 60? I think that's a really cool way to think about it. How did you get that? There's a bunch of different ways to look at this because of the way circles and triangles work. Make right triangles AED and BEC. That's really cool. I was not thinking about that. So I'm going to actually copy paste this diagram a bunch of times so that I have it for future reference. So we can look at all the ways to do it. So making triangles AED, I'm going to do this in red. So AED and CEB. The big idea for this one that is currently in chat is that as soon as you have a diameter and some other points on this, it's going to be a right triangle. As long as the hypotenuse is a diameter, it's going to give you a right triangle if it subtends an arc. That comes from the inscribed angle theorem. So the inscribed angle theorem says if you have an angle that is under an arc, it's going to be exactly 1/2 of that angle. I think this special version of inscribed angle theorem is called Thales theorem, so thank you, chat. I don't know exactly though, because it's just kind of like, you know, right triangle in a semicircle. But yeah, since this big arc is 180, that angle is going to be half of that arc. So that's why it's a 90-degree angle. And so that's how we know that both AED and CEB are right triangles. So I'm just going to draw angle CED right now. So just like a zoom in of what's going on. First of all, we have our red lines, right? These are the bases of the triangle. So I know that this is a right angle and that's a right angle. Okay, I don't think I drew this very well, but the idea is that those are both right angles, right? So it's not 180 degrees because there's an overlap. So adding this and this is 180 because those are both 90 degrees, right? But we added this middle one twice. What is that middle one? Well, it's the angle in AEB. Well, what's AEB? What's nice is that they're all radii. That's a radius of circle A, that's a radius of circle A and B, and that's a radius of circle B, but they're all the same radius, right? So that means that's an equilateral triangle, which means this angle in the middle should be 60 degrees. So in other words, 90 plus 90 adds this middle angle twice. So if I add 90 and then 90 and subtract 60, that will add up exactly the span of this angle, which means 90 plus 90 minus 60 is our answer. And that gives us answer choice C, which is 120. But there's so many other ways to do this too. I think one way I was thinking was looking at it, also inscribed angle theorem, in which case we're looking at CEB. So sorry, ECB. ECB subtends arc EB, right? It goes under arc EB and then it's half that. And so much like we discussed here, EAB is an equilateral triangle, which means this arc right here is based off of angle EAB, right? The arc EB, which I kind of haven't read, that's the same angle measure as EAB, and that's 60 degrees because it's an equilateral triangle, which means ECB is half of that. So this is 30 degrees. And in very much the same way, EDB should also be 30 degrees. So since ECD is a triangle, CED is going to be 180, the total degrees in a triangle, minus 30, so that's 120 as well. Two different ways to do the same problem. Cool.
Yeah, and now we're on to question number 24. We're almost there. So for this question, we have the digits 1, 2, 3, 4, and 5, which are each used once to make a 5-digit number, PQRST. So basically what this tells us is that, so what this tells us is that I'll have PQRST, which is a 5-digit number, and we're going to use the digits 1, 2, 3, 4, 5 each once. So we can see that PQR is divisible by 4, and so 4 divides PQR. If you're wondering what this this dash means, it basically just means that the thing on the left, which is 4, divides the thing on the right, which is PQR. Just like some fancy notation. We also are told that 5 divides QRS, and I believe that 3 divides RST. So we have 3 of these conditions, and first of all, we know that that's exactly right, RC. So we know a lot of things. First of all, we can look at this one first, right? So if 4 divides PQR, that means by our divisibility rule, 4 divides QR. We also can see that from 5 divides QRS, since that means that 5 divides S, but since 5 is the only multiple of 5 that we have, we know that S equals 5. So now we can move on to looking at RST and PQR. So this condition's already been gotten rid of. That basically just tells us that S equals 5. We also know that 4 is going to divide QR. So looking at all the multiples of 4 that we have, there's only 3 that I believe that satisfy 4 dividing QR. So we see that QR could be 12, it could be 24, or it could be 32. It can't quite be 52 because remember, we already used the 5 in S. So QR can only be 12, 24, or 32. Now we can move on to look at the third one, right? So 3 divides RST. What this means is, again, using our divisibility condition, we know that 3 divides R plus S plus T. First of all, we know that S is going to equal 5, I believe. And the second thing we know is that, the second thing we know is that PQRST, right? We know that our QR is going to be either 12, 32, or 24. So what this tells us that if we look at R is going to be 2 or 4, so 2 or 4. And we know that 3 has to divide this entire thing. So we can just take cases, right? We can say, first of all, say if r equals 2, then we know that r plus s plus t is going to equal 2 plus 5 plus t. And this has to be divisible by 3. What this means is that, 7 plus t has to be divisible by 3. So t can be equal to 2 or 5. But remember, we already used both of t. We already used both of t, and we already used both 2 and 5. And that's exactly right, yeah. I'll give you guys both the star. As soon as, yeah, that's exactly the right idea. So that means that we can look at 4 now, right? So if 4 is r, then 3 has to divide 4 plus 5 plus t. In that case, we have 3 divides 9 plus t, so t is going to equal 3. And that works. So just to recap, we know that r is going to equal to 4, s equals 5, and t equals 3. And now we're just left with p and q. But again, we know that qr is going to equal 24, so we know that q equals 2. And so the only digit we're left with to make p is going to be 1. And 1 is our answer. So it's really cool how divisibility rules are so powerful and they allow you to solve such a complicated problem. Remember, this is number 24. But knowing our divisibility rules is really important. And what is PQRST then? Well, PQRST is going to be 1, 2, 4, 5, 3. And you can verify that that indeed satisfies all the conditions.
Yeah, I think that last bit is always really important. Check your work. It doesn't spend that much time, and it might save your 5 minutes of work or 10 minutes of work from all going to waste, right? So that always works as well. But yeah, you'll probably end up having to do some sort of trial and error with these types of problems. But as Kevin did, you can always narrow it down a little bit so your trial and error is a lot easier. It's either a 2 or a 4, for example. Okie doke. Finally, we have number 25, which is this diagram. We have a triangle that's isosceles. So I'll mark that as well, actually. So these two sides are equal. And then from there, the base, so that, I believe that last bit has a little bit of a typo for 24. It should be 1, 2, 4, 5, 3. But yeah, for number 25, it's an isosceles triangle. Base of the triangle is 16, and the height of the triangle is 15. So we're looking for the radius of the semicircle. So a lot of things are sort of implied. It feels like we don't have enough information, but another key part is the fact that the semicircle is inscribed in it, which means it's tangent to the points that it hits. So that's a right angle. So this is essentially everything I know from the problem. I marked the side lengths, I marked the tangent, I have the isosceles, the two sides being equal. And now we have to use this somehow to find the radius. What's the big idea here? Use areas to find radius? We could. So I think that's a possibility, but with geometry problems, there's this one common theme that is always like the answer to everything. It's a theory of everything. There's generally one trick that we can look for that solves everything, and bam, there it is. Similar triangles. Now, which triangles are similar? So I'm going to name points. Let's just call this A, then B, and then C. And since this is the midpoint, I'll call it M. So which triangles are similar in our case? And then, I don't know, since that's like the base of an altitude, I'll call that H. It's the base of a height, right? So call that H. A little weird naming system, but it might help us out. Better than I feel like just doing a bunch of A, B, C, D, E. Okay, awesome. So ABM and ACM. Is making a rhombus a dumb idea? You're gonna have to explain what you mean there because I don't see the rhombus, but tell me and we can figure it out later. But let's look at ABM and ACM. So yeah, those are congruent, right? Those are the exact same, which is helpful, right? The triangle is symmetrical. But remember what we're looking for. We're looking for this orange line, right? So ABM is a right triangle and MHB is a right triangle. So that's helpful. So like right triangles, and why do we know they're similar? Well, the smaller right triangle has this angle, right? HBM, angle B rather, because angle B, there's only one angle B. ABM, triangle ABM has the same exact angle B, which means since they both have a right angle and angle B, the last angle, which I will make in dark green, these angles should be congruent, right? And so bam, they're similar triangles. Okay, so from there, let's just finish off the problem. So I'm gonna actually redraw the triangle on the side so we can make really apparent which sides are similar to which sides. So right now I have, let's see, B is the bigger angle. So BM, my letter's not clear. Okay, so from there, and then this is gonna be H. And let's look at the big one, right? The big triangle is gonna look like, has the blue altitude, right? That's M again. And then now we have B over there. And I guess you could look at it as C as well, but same thing. Okay, and so this matches up because angle B is facing AM in the big triangle, and it's also facing angle HM in the smaller triangle. So now let's remember what our values were in the diagram. So the height is 15. We have that. We're looking for the orange length, or we don't know what that is. We have BM. BM is half of the big side, right? So that's going to be 8. And we're missing one of these side lengths. Well, so BM is in this one as well. This is also 8. So we don't have quite enough information because, like, I know that 15 corresponds to this side, but there's nothing there. 8 corresponds to this side. There's nothing there. This corresponds to the hypotenuse. The hypotenuse corresponds to each other, but I don't have anything. So what can we do? I don't have enough information, it seems, right? But what's nice about 8 and 15 especially, how do I find some sort of pair that tells me what the ratio is from one triangle to the next? Remember, the big idea between similar triangles is that the side lengths are all multiplied by some value. It's like using Google Docs, like where you stretch an image, right? So, for example, similar triangles would be like doubling all the side lengths or something. Pythagorean theorem, perfect. So we use our handy dandy a squared plus b squared equals c squared, and you'll get that a squared plus 15 squared is equal to the hypotenuse squared. And it works out that this is exactly 289, which is also exactly the square of 17. And looking at the answer choices, actually, never mind. There are some radicals in there, so it's not immediately apparent that you would get a nice square root. But 8, 15, 17 triangles are pretty common. You'll see them a lot. It's a nice Pythagorean triple. So what this tells us is, what's the ratio between the two triangles? This gives us a pair. What do I multiply the side lengths by to get from the smaller triangle to the next one? What do I have to multiply by? What's the common ratio among everything, basically? And remember, the only side I know so far for this triangle is 8, right? So let's just use that. We're using this side. What's the ratio? Quick question on letter the angles. Yes, so for the angles they do. For example, AMB would describe the right angle, right? Because M is in the middle. That's M. But BAM would describe that angle in that corner. Yeah. So 17/8, right? Perfect. So basically, for example, to get the original hypotenuse on the smaller triangle, which was 8, to get to the bigger one, I had to multiply by 17/8, right? So that's our common ratio between these two triangles. This is 17, that's 8. 17/8, right? So I need the orange side of the smaller triangle. So in the big triangle, that's 15. So 15 is equal to 17/8 of whatever the smaller triangle is. And this is the radius in the original problem. This is the radius of the semicircle. So 15 is equal to 17/8 of R, right? If this is R. So 15 is 17/8 of R, which means that to get R, I take 8 over 17 times 15. And it makes sense, right? 8 over 17 is smaller than 1. So I'm getting a number smaller than 15. That checks out. And bam, that's 120 over 17. And I believe that is answer choice B. Generally, the big takeaway is similar triangles solve almost everything. Another way to put it is that you always have to match sides up. For example, if I look at the hypotenuse to the long leg in this triangle, I'm looking at the hypotenuse to the long leg of the shorter triangle. You have to match up the sides. And then bam, there's only one variable and we can solve. So there you go. But I also want to go over I want to see what you guys are saying about the rhombus. Create another triangle to get a rhombus with a full circle in it. I have a feeling you're going to end up having to do the exact same thing where you just take similar triangles, but we never know. So let's give it a shot. So it felt like this was like an avatar for a minute, but okay. So, oh wait, let me just cut through the circle real quick. Okay, that's cutting through the circle. And then from there, oh wait, that's way too long. Okay, from there, we make a triangle going up. Actually, wait, this is still way too long. Always make sure your diagrams are well drawn, because that might make some answers really apparent. Okay, uh-oh. I'm trying to make straight lines, but this is not working out very well. So that and that, bam. Okay, so I'm wondering what we can do with this. Because like, we still have to rely on the fact that these are tangent. And I'm not sure there's that much other information we have, right? Other than the stuff that we were originally given. So that's 16. And the height this time all the way around is 30. Do you have any ideas, Kevin? I'm not sure if there's much else you can do with this. I feel like it's the exact same, no?
Yeah, I feel like it might just be like kind of this sort of similar to the first solution, I want to say.
Yeah, I feel like you're going to have to end up doing similar triangles with this anyways. But yeah, good idea. Honestly, thinking about reflections and connecting to a full circle is a great idea, and it does help you solve some problems. And I think that's generally a really good way to look at stuff. It's, especially with geometry, you kind of just got to experiment around and then see if that gets you the right answer or not. So overall though, good stuff. Alrighty, those are all the questions, no? So
yeah, I think that should be it.
way to go, everybody. Hopefully that makes sense. Hopefully you guys learned something. Stuck through it. Almost used up the entire 2 hours, but really good stuff overall. So yeah, great job, everybody. Way to go for sticking around. Appreciate all the answers in chat too.
Yep, thank you everyone, and have a great day.
Thanks, guys.
Bye-bye.
Bye-bye.
Thank you, bye.
Put a hat back on. Beanie. It's nice and cozy. Keeps the earbuds in. Alrighty. I think the game ended. I think Argentina won.
Oh, really?
Yep.
What's the score?
2-1. Australia's goal was an own goal, apparently.
Wait, what?
Yeah, Argentina. So I guess Argentina scored 3 goals, but it was really it was 2-1.
Yeah. I don't think I've seen an own goal in a long time.
All right. I think there's been a few. Sometimes it's like accidentally like trying to defend, and then it just magically appears in your net.
I know, like sometimes I try to like kick it back to the goalie, and then
right.
What happens?
We can always here. I don't know if anybody's still in the other room, but if people are still saying bye. This is the World Cup. Hold up, there it is. Oh, hold up. I gotta re-edit this such that. Okay, there you go. That's messy.